Okay. So I'm going to show you another way to solve proportional relationships and unit rates here, especially when you have to figure out a missing value in a table. Sometimes you don't even have a table, you just have the question. So you have your X and your Y values. So let's just say that X is going to equal lions. So your X is the lions. And your Y, those are your monkeys. So we know for every 2 lions at the zoo, there are 7 monkeys. We have to figure out what is going to go here. So I'm going to teach you a different method, okay? And basically what you're going to do is take what I've taught you as far as what are ratios, right? It's a comparison. So lions over monkeys. So I'm going to just write this down. So lions over monkeys. They said for every 2 lions, there are 7 monkeys, right? And I wanted to find out how many lions does it have, okay? Because there are 49 monkeys, so we already know that. One thing that I want to teach you is that when you are dealing with proportions, this can help you in many other topics in pre-algebra this year. If you can learn this, this is going to help you out with so many other topics. We're creating a proportion here. They're saying for every 2 lions, there are 7 monkeys. And we already know that there are 49 monkeys, but we need to figure out, well, how many lions is that? So, most important thing, if I'm talking about lions on the top number is 2, then this top number also has to be about lions as well. So if your top number is lions, then obviously the top number here is lions. Down here, the monkeys, if your bottom number represents on the left monkeys, then also the one on the right. And that is just, you could use this for anything. So if it's lions over monkeys, it's got to be lions over monkeys on the other side. Now, what this is going to create is a proportion. You can solve this in so many different ways. You could say, well, how do I get from 7 to 49? You could say I multiplied by 7, right? So whatever you do the bottom, you can do the top. Well, I already know, well, gosh, that must be 14, right? There's several different ways to do that. You can do it that way, or you're creating a proportion. And what do I mean by a proportion? Well, if I told you 5/10 equals, let's see, something 1 over x, could you tell me what would go into that x? Dane, could you tell me what would go in that x?
2.
Exactly, you know that. 5/10 equals 1/2. That's a proportion, we know that. Well, because let's see, if I divide by 5 on both sides, or top and bottom, I now know that this has to be a 2. Well, I'm going to show you another method that you can do, which is called multiplying your cross products. We want to figure out what x is. And sometimes it's not as easy as looking at it. Sometimes you're going to end up with a decimal. So what you're going to do is you're going to take your cross products, and they have to equal each other. Okay? Does that make sense? Okay, so what I want you to do is multiply those 2 products and tell me what you get. Well, for the first one, you get 7x, correct? 7x. Well, what does that mean? That means that I don't know what x is yet, right? So what we're going to do then is we're going to multiply 2 times 49, right? And we're going to get 98. So I'll use another color here. So this is 98. This has to equal 98. So 7 times something has to equal 98. Well, what you're going to learn in algebra is that we can solve this as an equation. You always start with the diagonal with your variable. So this is 7x equals 49 times 2. Well, just like with order of operations, I'm going to solve this first. So 7x we know equals 98. Well, 7 times something equals 98. Well, what you're going to learn later is 7 times something. I'm going to do the opposite to figure out what the answer is. So I'm going to divide both sides by 7. 7 over 7 cancels them out, and then x is going to equal 14. Does that make sense? So my answer, x equals 14. So that's one way. You could just look at this. You could also say, some of you already probably realize this, that you could say 2 times 49 is 98. Divide by 7, right? 98, divide by 7, that gives me 14. Yes, that's kind of a shortcut. All right? So solving problems this way, it's going to be useful as we move forward in math. So sometimes they don't give you a table to solve. And that's why I wanted to show you that I created actually the table here, right? This was my work, and I did lions over monkeys. So the table wasn't here. I just used this problem as an example. I created the table. The table did not come with the problem. So you have to know how to take the problem and figure it out, whether you make a table, you make a proportion, and set it up that way. Does anybody have a question for me before I move on? Anybody?
Ms. Zell?
Yes.
So what do you do if you do the cross way to solve it and the x equals a decimal? Is there something you do, or is it just?
No, I mean, that's just what it would equal. I'm just saying sometimes it's not as obvious, you know? Sometimes you're dealing with some very odd numbers that you have to actually do the math to figure out. And when we get to a problem like that, I'll show you.
Ms. Zell?
Yeah.
What does the X mean?
Good question. So to prepare you for that unit, X is a variable in that case, right? It's an unknown value. So in math, in pre-algebra, you start to kind of lean away from using X as a multiplication symbol and more as a variable. So it's kind of like a substitution for a missing number that we have to find. Does that make sense? Okay, so we're going to move into some algebra here. We're going to talk about a rate of change, and think about if you are hiking in the mountains. We have some beautiful mountains, like, you know, near Charlottesville, Old Rag, if any of you hiked Old Rag. There are some steep slopes as you hike through those trails. So slope is a big factor in mountain backpacking. And what I'm going to teach you is, well, how do you know what the slope is, how to find it, okay? Because when you are going mountain backpacking, you need to know the steepness of the trails and the ridge lines so that you can plan your route to the peak of the mountain, climbing up. So in this lesson, you're going to learn how to determine what that rate of change is. And by the way, you're going to learn that rate of change is the slope, okay? And I'm going to show you how to figure that out in graphs, in equations. You're going to learn about the line, the steepness of the line. So I put three videos in today's folder. I don't know if any of you watched them prior to today, and if you did, this probably makes more sense. But I'm going to ask that if you didn't watch these videos, that it is a must. You really need to watch those videos, and it will make so much sense. And we're going to build on this. So tomorrow's lesson is more going to be about, well, what is slope? All right. here is another example of some peaks and slopes that are very steep. So how can we, I need to make that correction. How can pre-algebra help you plan your backpacking trip to the top of this mountain? So I'm going to teach you what slope is a little bit later, but slope is basically the rise, how high, and the run is the steepness of the slope. All right, so you guys have seen the ratio tables. We've been doing the ratio tables, and now this is probably going to make a little bit more sense now since you've experienced using ratio tables. So think about, and we talked about this if you got a job and how many hours you work and how much money you're going to make. So when do you start? What will you do with all your money? And most importantly, how much will you make? Some of you already making money now. Maybe you mow lawns, maybe you get allowance, maybe you babysit, maybe you dog sit. So here's the pay scale. Now our X is going to represent hours worked. Now, f of x, which is a more advanced term, it's called f of x, but we're going to just call it y for now, okay? You might see f of x later, but it is your y. So that's going to be your money earned. So 5 hours worked, $70 you earned. So what is the rate? What is his pay per hour? So what's the unit rate? Figure that out on your paper. Does anybody have that? Anybody have that? Ava, how did you get 14?
I divided 7 by 5 and I got 14, and then I divided 120 divided by 10.
You mean 70 divided by 5?
Yeah.
Yes. So remember, if you take y over x, right? 70 over 5, that's going to equal 14, right? If I take 120 over 10, what do you get?
Michelle, I can't hear you.
Pardon? Question? All right, if you look at 120 though, and you divide it by 10, do you still get 14? Do you still get 14? No.
No.
What about 170? No. So they're all different. This one is correct. Yes, $70 divided by 5, but I'm going to show you how to find that. So this is going to be called the rate of change. So we'll come back to that. Let's go to the next slide. So the way to find this out is how much will you earn? So you have your X, which is your hours worked, and your Y is the money earned. So the way to figure that out is we're going to do the same thing. What is the change in Y divided by the change in X? So we're going to take it another step further. So watch this. What you have to figure out is, what is the change in Y? And what do I mean by the change? The change. I want you to look at 70 to 120. Subtract the 2. What do you get? Subtract the two numbers. And just take the higher number. So take 120 minus 70. We're not really dealing with negatives here. 50, right? Okay. So subtracting the two. All right, 120 and 170. So 170 minus 120. Do you get 50 again? How about 220 minus 170? Do you get 50? Yes? Okay. So that is the change in y. So 50 is the change in y. So change in y is right down here at the bottom. What would the ratio be? The ratio of change in y divided by the change. So the change in y is 50. So y, the change in y is 50. Okay. Now let's look at the x. Subtract the two values, the two x values to get the change in x. So 10 minus 5. What is that? 5, right? How about 15 minus 10? 5. 20 minus 15, 5. So what is the change in x? 10. So now what? The change in y is 50. The change in x, which is hours worked, is 10. Now,
How is it 10?
How is it 10? 5. I'm sorry. You're right. Thank you. 5. I'm already trying to write the answer. Thank you. I was already trying to write the answer, which is what? What is the answer, Charlie?
10.
Yes, I was already giving you the answer. 10. So guess what? What do you think that tells you about your new job? How much do you make? Yes, you make $10 an hour. So I'll show you in a minute how that works. All right, so the rate of change from tables. In the last slide, you found that the change in y and the change in x is $10. This is the rate of change. It means that you will earn $10 for every 1 hour you work. The rate of change is a ratio, the change in the y values over the change in the x values. And these are little symbols right here we're going to use for the rate of change. Which you're going to learn is the slope. So the rate of change is normally written with these symbols. It's the triangle. So this represents the rate of change. So the change in y over the change in x. Question? All right. So let's look at this one. If the value of the change in y over the change in x is the same every time, the function has a constant rate of change. Functions with a constant rate of change are always linear functions. Now, what you're going to learn is linear functions. Do you see a word in linear? Do you see a word inside the word linear?
Line,
Yeah.
ear.
There's a line. So a linear function will form a line. That's what linear means, line. So when you have a constant rate of change, it's going to form a line, which you're going to learn about slope, because in order to find slope, you should be able to see a line, right? How steep is the line? So the constant rate of change we're going to take the change in y. The change in y is the difference. So 10 minus 5, 15 minus 10, 20 minus 15 is 5. So the change in y is 5 over the change in x. So 0 to 2 is 2. 4 minus 2 is 2. 6 minus 4 is 2. Okay? So the change in y over the change of x is 5 over 2, in which what you're going to learn later, the slope is rise over run. And that is going to be your slope of the line. Meaning, you're going to learn this later. You're going to go up 5 and run 2. Up 5 over 2. Up 5 over 2. Those are going to be your points on the line. Does that make sense? Yes? All right. Same thing on the right-hand side. I know I wrote over it. So the change, I want you to notice though at the bottom of this chart here, do you see this right here? Do you see that? Notice that the change is a +5 every time. 5, 10, 15, but look what happens. You're going from 15 to 30. And the reason why is you're going from 2 to 4 to 10. So if you take 15 over 6, which is the change in y over the change in x, remember, you can always reduce. So if I divided by 3, I would get 5 over 2. And the reason why is because I'm jumping from 4 to 10. Therefore, I will need to reduce it. 5 over 2 is going to be the same thing as over here. Does that make sense? All right. All right, go ahead and try to fill in this chart. So for each input-output table, subtract the 2 sets of x values to get the change in x, then subtract the 2 corresponding y values to get the change in y.
For rows 1 and 2.
Yes. So what's the change in y?
What?
The change in y is a +5.
And the change of x will be +1.
So 5 over 1. All right, let's go to rows 2 and 3. So we have a +5 and a +1. Same thing. Let's go to rows 3 and 4. Okay, again, +5 +1. Yes.
Oh, why'd you put a 5 in the rows 2 and 3, like for x? For rows 2 and 3, you put, yeah.
You are so good. Thank you so much.
No
All right,
problem.
so did you look at your question below? Did you get the same rate of change every time? Yes, right? So what's the rate of change? 5 over 1. The rate of change is also called the slope of the line. Does that make sense? Then I'll show you more what that is when we come back. All right, questions? So we will finish the rest of our activity when we come back from lunch.